Good morning, students. Today we will discuss about the carbon chapter, class 10th. The most important chapter we'll discuss and we'll study what it is given about that carbon. Okay. So what they have given is carbon. Okay, carbon and its compounds. Okay. So let us see what is behind this known metal. First thing is carbon. Symbol is C. Okay. Now its atomic number is 6. Atomic mass is 12. If I consider about isotopes, which we have I think studied earlier, that is carbon is C14 and C12. Okay. And same atomic number and different mass number is known as isotopes. Okay. So these two are the isotopes. Now, what we are discussing now is the most important thing about this is that first one, it is a non-metal. Okay. More thing we have to discuss about is that it has or it contains two most important property it possesses. First one is catenation. Second one is tetravalency. Now, what these two property means? See, carbon is available in abundance. If you go and found in the earth crust, on 13th number you will found carbon. That is, it is in large quantity. It is in abundance. Okay. Now I'm talking about two properties: catenation and tetravalency. What is catenation? Catenation means carbon makes bond with other carbon atoms. Okay. One more thing is about tetravalency. Tetravalency is that carbon. If I am talking about carbon, that is, atomic number is 6. So if we divide this atomic number according to the electron configuration in which shell number of electrons will be, so I will say like this: 2, 4. So in first shell will be 2 electrons and next shell will be 4 electrons. Now 4, it has only 4 atoms in its valence electron, valence shell I can say. Now he needs more 4. So that is what its next property, that it makes bond with other atoms of carbon with 4 other atoms of carbon. That is what we say about tetravalency and catenation. So these two important property predicts about the how the carbon makes chain with carbon. If I say if in non-metal, apart from carbon, we have silicon, which makes chain with other silicon atoms. But in this we will not discuss about that, because this chapter name is carbon and its compounds. So I will talk about carbon and its compounds. Okay. Now, so it needs 4 more atoms to complete its octet. We have already discussed, I think, we have studied also in previous classes that how the atom can complete their octet. How they complete? By sharing or by transferring. Two kinds of bonds are there now. This type of bond we say it is covalent bond. covalent bond is a bond with a very strong bond it is, and it's a very stable bond. Okay, so this is about non-metal, how carbon breaks bond with other carbon atom. Why? That is the bond is called covalent bond. Now, one more thing or other thing we can now share about its compounds. Now, what happens? Carbon makes compound with more other elements, like you can say hydrogen, nitrogen, oxygen, lots more are there. But what happens when carbon makes bond with hydrogen? We'll say that is hydrocarbons. That compound is called hydrocarbons. Okay, that compound is called hydrocarbons. So first one I am discussing about is first one is methane. Okay. Before going too deep in this hydrocarbons, let me tell you the thing is about catenation and the tetravalency. That is, they make bond, single bond, double bond, triple bond. Now, what's the story behind single bond, double bond, and triple bond? Let us discuss now. They have given the single bond. Now, single bond means that, for example, if I take hydrogen, okay, here its atomic number is 1, it shares 1 electron. So, 1 electrons they are sharing. That is why we say single bond. That is, I say about is single bond. If I am talking about oxygen, what will happen? Atomic number of oxygen is 8. So, electronic configuration will be 2, 6. So, it is showing 6. Two, 4, 6. Now, it needs 2 more. So, what will happen? So, it is sharing 2 pair, 1 pair, that is 4 electrons they are sharing. That is why I say it's double bond. Sharing, you can say it's double bond. Now I am talking about triple bond. Let's take an example of nitrogen. Atomic number is 7. Now, how we'll divide? We'll see 2, 5. Okay, 2, 5. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So now, what will happen? It will share like this. It will share like this. So they are sharing 3 electrons, 3 each electrons. So we will say it is triple bond. It's triple bond. They are sharing 2 electrons each. So double bond. They are sharing 1 electron each. It's single bond. So that is how they have divided bonds according to the distribution of the electrons, the sharing of electrons, I can say more. Okay. So now after doing this, let's move to the hydrocarbons. Okay. Now about the hydrocarbons, they have divided according to this only single bond, double bond, triple bond. Now what about single bond? They have they have the general formula CN H2N plus 2, and will be number of and maybe consider like natural number. If I consider 1, so it will be 4. That is CH4, and that is called methane. That is what we say is methane. Why? N for single bond and meth for 1 carbon. And that nomenclature is given by IUPAC. IUPAC. IUPAC, International Union of Pure and Applied Chemistry. Okay, so they have devised that how we can name a compound. Okay, now if I increase carbon, what will happen? Like this. This is what. Okay. Now here you can see we have two carbons. So what will be its formula? If I put n is equal to 2, H will be 6. That is called, two carbons are there. So it and N is for the single bond. Later on we'll discuss how this name changes. Lot we have to discuss, but first concentrate here. What way this is given is about, like this is with ethane. Okay, we have two carbons. So IUPAC have given the nomenclature how we will name a compound that is called hydrocarbon. First one is we need to see how many carbons are there. Second one, we need to see here which bond is this. Single bond, double bond, triple bond. Right now I am talking about single bond. We'll move on to later on double bond and triple bond. Okay, so let's move. We'll see more examples for this. Here what I got, if I put n is equal to 3, that's for the alkane. Okay, this is saturated hydrocarbons. One more name I am giving to it is saturated. First, how will you define this word? Is saturated hydrocarbons, they completely burn, they burn completely, do not leave any residue behind. Second thing, no pollution. Third thing, single. So that is why we say they are saturated hydrocarbons. Okay, alkane, which we were talking about, alkane is like, now if I increase 3, how many H? 8. That is called propane. How will now what will be the structure? Like this. Okay, this type of structure is called straight chain. This type of structure is called, if I say, is straight chain. Now, if I increase more carbon, if for example I am talking about 4, C4, how many H will be? 10. That is what they are called butane. Next one, 5, it will be 12. That is called pentane. If I write 6, it will be 14. That is called hexane. Okay, so we can increase the number of carbons, then according to it, its naming will be defined. Now, let us draw a structure of pentane and hexane. That is how we can draw the structure. C5, here it is C6, here it is C6. Okay, so what they have given like this. Now, more thing is, so that structure is called straight chain. Okay, that is called straight chain. And one more thing is, in single bond, number of hydrogen atoms are more. We'll see the difference between a single bond and a double bond and triple bond that as the bond increases, number of hydrogen atom reduces. So this is the basic, we can say, a difference you will find in single bond, double bond and triple bond. Okay, now let's move further. So what I have drawn here is about alkane, that is about single bond, that is saturated hydrocarbons. Now we'll move to further about okay, these are the straight chain structure. Now I'll take example of butane here. I will show you how branch structure will form and then ring structure will form. Okay, so let us see and how their naming will change. So now I will draw two different structures of hydrocarbon. Like I'm talking about butane. Formula, molecular formula will be same, but the structure will be different. See how. First one, I have drawn that straight chain. Okay, this is the straight chain. Okay, C4H10, that is what I say is butane. Okay, now I will draw different structure, but formula will be same. That is molecular formula will be same. How? See. Okay, so now what they have given is like okay, that is how they are making it. Now this structure is called branching. This is a straight chain, this is a branch chain. Okay, so that is how we can make it. So same formula will be there. Okay, that's how butane. Straight chain is there, branch chain is there. That kind of structures will be called isomers. But I will say a new word, that is isomers. So branch chain is there, straight chain is there. What we find in this unique, which is in this isomers, is that molecular formula for butane, see, same, but structures are different. That we derive a word called isomers. Okay, so lots of things are there in this carbon chapter and its compounds. Okay, so now you are able to identify that we have studied two structures, that is butane, that is straight chain and branch chain. Now apart from this, one more structure is there. That structure is called ring structure. Now I will explain what is about a ring structure and how it is different from these two structures. Let us draw one more structure now. Okay, I will draw later on. That structure is called ring structure. Now its name will also change. How many carbons? 1, 2, 3, 4, 5, 6. Hex. Single bond A. But this is a ring structure. So we will say it is cyclohexane. It is cyclohexane. Now, so its formula will be, hexane formula is C6H14. Okay, so I can draw like this also. straight chain, branch chain, and third one is a ring structure. Okay, so lots of things are there. Now, apart from this, okay, I will show you more about this is cyclohexane. Now, I will draw this again. See? Now, what's the difference between this and this? What is this? I will tell you. Now, you can easily distinguish in this that this is in double bond, this is single bond. Now, in double bond, the quantity of hydrogen atom will be reduced. Okay. Now, what will happen? What its name will be? C6, 6 carbon is there, and hydrogens will be 6 only. If I draw this, you will find this that we have 6 hydrogen. So that structure's name will be benzene. Okay, that structure name will be benzene. Okay, so that is how we are able to clarify now. We are able to find a difference now that how does how or I can say the type of structures now. Now straight chain, branch chain, and that is called ring structure. So that is how, see, their naming also changing. So that is the difference we can now easily identify between single bond, double bond, triple bond. Okay, let us see how the naming will be changed in double bond. Okay, how will change the naming in double bond. Okay, then let us draw diagram for this for the double bond. See now. Now in double bond, what will happen? The first hydrocarbon will be not with. We have started the double bond structure from 2 carbon atoms. So its formula will be CnH2n, and that is why they are called alkenes. What they are called? Alkenes. Now, if I say one will not be possible, so take 2. C2H4. So C2H4 means that is, it's called ethene. It for the 2 carbon atoms and ene for the double bond. How its structure will be? If I clarify this, how its structure will be like this. So you will have H here. You can see the number of hydrogen atoms has been reduced. Number of hydrogen atoms has been reduced. So that is what they say C2H4 ethene. If I go further, let us take one more example. C3H will be 6. That is called propene. How? See, C triple bond. Now here it's double bond only, not triple bond. So here C3. So H will be, if I say H will be 6. So that is how they have made the structure. So now it has reduced, that is what they have made the double bond, that is called alkene. Now it's a triple, we'll take more example first before going to this. So this is double bond. Now we'll move to the triple bond. But before that, let's go for more examples. So it will be more clear. Okay. But first see how the basic difference of C2H4 is there. Okay. Now what will next will be C3H6 will be there. So we'll draw like this properly. So that is how we can show. Okay. So that is how we can easily, see now, propane here, single bond, hydrogen atoms are 8, but here hydrogen atoms are 6. Okay, so that's how we can easily draw more structures which will easily distinguish between single bond, double bond. Now let us move to the triple bond here. I am drawing here itself so that we can easily clarify single bond, double bond, not triple bond. Now triple bond means this formula, and that is they are called alkynes. First one, same from ethene, ethene. Here I will write is ethyne. Okay, how will you draw the structure? Ethyne for that. If I take 2, C2, H2. How will you draw? C. That is called ethyne. First hydrocarbon. Okay, I must tell you now, as IUPAC have named the structure according to the rules they have made. So now they have two names, like ethyne is a IUPAC name. Now next name is common name. Ethyne is a welding gas, if I say. Okay, ethyne is a welding gas. Another name is acetylene. So if you see someone is doing welding, welding is what? Breaking or joining of two iron nails like. Okay, so that is how, which gas we use in this is this ethyne gas, or its another name is acetylene gas. Now these compounds have two names, IUPAC name and a common. Okay, we'll discuss more later in this. Okay, my first motto is that we first should be clear with this, that is single bond, double bond, triple bond. Okay, so what is they have given? So this is what they have given in this. That is how we can easily now identify this is single bond and this is triple bond. We can take more examples for triple bond. If I say now C3 at 4. Got 3 to 6 minus 2, 4. And that is called prop bole to prop is here 3 carbons, and triple bond I say propyne. Now how will you draw the propyne structure? We'll see. Okay, it will be like this. Clearly see these structures. They are very, very more important. Okay, because they will not only help you in this class, 4th class, 10th class, but they will help you in further, in future also. Okay, so because in 11th also, this structure will be there, but in advanced form, in more detail, big structures. We'll discuss later on, but right now, focus on this. Now this is what? C3, propyne. How many H? 4. There will be H, okay, here H, and I can say H and H. Okay. So that is how I can easily do that. 1, 2, 3, 4. Okay. So that is what they are doing. So that is how we can easily, now we can see triple bond is there, alkyne, double bond is there, alkene, single bond is there, alkane. So you can easily now identify single bond, double bond, triple bond. Okay, so that is what they are called hydrocarbons. Now, okay, so this is how the nomenclature defines by the IUPAC. Okay, so this is, now let's move further. Now I will talk about functional group. Okay, this just I have taken few examples to show you how the structure will be like straight chain, branch chain or cyclic structure. Okay, now next topic is about, we'll talk about this That is the structure called functional group. How we will see that naming will change according to it. Okay, let's move to this. We'll discuss one by one all the structures, all the functional group, and how these naming will be changed according to it. But we have only few. I think only 5 functional group we will discuss here for this class 10th, and furthermore will be higher classes. So now what is given in this about is functional group first one, and I will show you how their naming will be changed. Okay, so first one is hello alkane. Hello alkane. First one is about hello alkane. So how will naming will change? Like it has only two, Cl and Br. Like for example, which we have discussed right now about the methane. First hydrocarbon, that is also called natural gas. So how we will write? Like this. This is called methane. Now I will replace one H by Cl. So how its naming will be? With one carbon, or now I have reduced one H. I have replaced one H, sorry, by Cl. So I will write methyl chloride. That is called methyl chloride, or in its another name will be chloromethane. Now remember that we need to consider, or we need to we have to take care of these compounds have now two names. So that is how its name changes. So first functional group which I am talking about is hello alkane. That is Cl. Now one more. Okay, like now I will use Br instead of one H. Same, one carbon, so I will say meth. One H has been replaced, so methyl, and Br means bromide. Methyl bromide or bromomethane or bromomethane. Okay, so these two. Haloalkanes. Okay, so haloalkanes now we can easily, they have given only two, chloro and bromo. So no need to worry. Very easy, to remember. Okay, now haloalkane is a first functional group. See how when I apply this group, their naming changes. Okay, so that makes a lot of difference. Now we'll talk about second one. Second one means second functional group. Second functional group means alcohol. Okay, alcohol. Its functional group is OH. OH. Now here, OH. Okay, that's how they are saying OH. So now its naming is changed. With one carbon, alcohol is there, so I will write methanol, OL. Remember that OL has been taken from OL. Suffix. In English we have studied about two words, suffix and prefix. Suffix means the word after, prefix means word before. So I have used after, last two letter of this word. So that will be suffix. Alcohol with nol, ethanol, propanol. Okay, so its another name will be, what will be its another name? Methyl alcohol. Another name will be methyl alcohol. So now we know that these compounds have two names. One chemical name, another one common name. Now we'll move to the another functional group. Okay, third one. The third functional group will be aldehyde. Okay, now we'll take aldehyde. We have done two groups. We'll do three more. Only three more. We'll take now aldehyde. Aldehyde. That is CHO. CHO. If I take the example of this, C, here I will write H, and here I will write HO. So its naming will be, how will you define like this? CHO is there. So if I say its name will be eth, two carbons, and we have this group, so we'll say ethanol. Okay, so we'll say ethanol. Here we have CHO. So by this we can easily identify. See, here I have used a prefix al, ethanol. So that is the third functional group, and that is how the naming changes. So by this you can identify this group is aldehyde. Fourth one is there. Now fourth one I am talking about is, after aldehyde we have ketone. We have ketone. Now ketone group is, how will you identify? Oh, that is how you identify. Now take an example. See. So now you can see here, you can add H, we already know that. So now it's ketone. So what its naming will be? 3 carbon. Prop, okay, none. Propanol. So propanol, here you can see 1. Propanol 1. Here I am using suffix. So easily you can identify its name, propanol or propane 1. So now we have two names. That is common name and a chemical name. Now move to the last functional group, that is called carboxylic acid group. Okay, that is called carboxylic acid group. Now carboxylic acid group. Here we can say about carboxylic acid group means, how will you identify? Like this. Okay, like this you can identify. COOH. That is how you identify that this group is carboxylic acid group. Okay, let us see in example. For example, if I take this, now you can easily identify how many carbons are there. 3. So it will be prop. Okay, prop will be there. Propanoic. Propanoic. It will be there. Okay, propanoic acid. Now propanoic, OIC. OIC. Last one you can say, last two words are taken. So that is why they are called propanoic, butanoic, pentanoic. So that is how we can easily identify from this that which functional group we have applied, and according to it their naming changes. So these are the functional groups. So we need to remember that, and we'll practice more and more structures in carbon and its compounds. Okay, we'll deal with study later. Okay, so I hope you are able to connect with me how they have, I am able to explain. If you have any doubt, you can comment, like, share, or ask any kind of doubt. Okay, thank you.